This video will be covering Module 2, Homework 6 notes. We're going to talk about polynomial functions. So, starting off for a definition, a term is a coefficient or the product. Remember, product means we're going to multiply of a coefficient and an exponential expression. So, for example, a term is 5x squared. 5 is the coefficient, x squared is the exponential expression. So identifying each term, we have 5x squared plus 2x minus 8. So 5x squared is a term, 2x is a term, negative 8 is a term. So remember, notice I have the negative going with the 8, so that's negative 8. The positive going with the 2x, so that's positive. So note that terms are separated by addition and subtraction. So here we have 3 terms. So a polynomial contains many terms. The degree is the sum of the exponents on the leading term. Remember, sum means we're going to add the exponents on the leading term. For this, it's going to be on the variables, and I'll come back to show you why. But we're only going to look at the exponents on the variables. So on variables only. I'll come back to talk more about that in a minute. And last but not least, a leading term is the term with the largest exponents. So our examples ask us to identify the leading term and the degree of the polynomial. So starting off, so we have example 1, 5x cubed plus 3x squared minus x plus 4. So identify the leading term, the term with the largest exponents. So 5x cubed is our leading term. And that degree, the largest, the sum of the exponents on that leading term is just 3. So next, example 2, 3x cubed y squared minus 6x squared y plus 7x minus 10. So this first term of 3x cubed y squared is a term with the largest exponents. So that is going to be our leading term. So that's going to be our leading term. Our degree for that leading term, the sum of the exponents. Our exponents are 3 and 2, so adding those up, our degree will be 5. Example 3, we have negative 4a squared b minus 7a cubed b squared plus 8a minus 4b. So here our leading term will be this negative 7a cubed b squared. It's a term with the largest exponents. Notice that negative goes with the 7. So that is our leading term. The leading term does not have to be the first term, so be careful about that. Our degree is the sum of the exponents. Our exponents here are 3 and 2. So 3 plus 2 will give us 5 again for that degree. Example 4, we have 5 cubed x, y, z. That's our only term, so that'll be our leading term. Before we find our degree, let's simplify this. So 5 cubed, I can do that in my calculator. 5 times 5 times 5. 5 to the power of 3 will give us 125. So I can rewrite this as 125 times x times y times z. That's why we said up here, this 3 is an exponent, but I can simplify that. So I'm only concerned about the exponents on the variables. So here I have 1x, 1y, 1z. So our degree, adding those up, 1 plus 1 plus 1, will give us a degree of 3. Last but not least, example 5, we just have 5. This is our only term, so this will be our leading term. For our degree is the sum of the exponents on the variables. There's no variables, so that means our degree is 0. Another way to think about this is I can rewrite this as 5x to the 0 power. Because x to the 0 power is 1, that's just 5 times 1, which is 5. So here you can easily see that our exponent for the leading term is 0, so our degree is 0. So next we're going to find the polynomials, our different types and degrees. We're going to identify different types of polynomials. So a definition. A polynomial is a finite, meaning it has a beginning and an end, sum of terms of the form to where some number times x to some power, when those powers could be 0, 1, 2, and 3, so positive whole numbers. Positive whole numbers for our exponents. So examples of polynomials: 4x cubed plus 2, 2 minus 5x cubed plus 2x, 4x to the 10th plus 2x to the 7th plus 3x to the 8th plus 4x plus 3x squared plus 1. But it's not going to be 5x to the negative third power. We cannot have negative exponents. It cannot be x to the 2 over 3 power plus 5x because we cannot have fraction exponents. And it cannot be the square root of x plus 2x squared because we cannot have radicals. Radicals are also fraction exponents, which we'll see later in the semester. So these are polynomials and these are not polynomials. Remember that terms are separated by addition or subtraction. So our different types of polynomials are classified based on how many terms there are. So for example, a monomial has one term. So for example, like 4 and like 3x squared. A binomial, bi means 2, contains two terms, so x plus y, or 6y squared minus 2. Lastly, a trinomial, tri means 3, contains 3 terms. So for example, x squared plus 2x y plus y squared, or negative x to the 4th plus 3x squared plus 0.1. So we're going to classify each of these polynomials, or all polynomials, as monomials for one term, binomials for 2 terms, trinomials for 3 terms, or none of these if it has more than 3. We're also going to give the degree. So for example 1, we have x squared minus 8x plus 16. So I have 1 term, 2 terms, 3 terms. So because there's 3 terms, we are going to have a trinomial. So x squared is a term, negative 8x is a term, plus 16 is a term. Giving the degrees, we have to find our leading term. Our leading term is a term with the largest exponent, so that'll be x squared. So here our degree is the sum of the exponents for that leading term, which will be 2. So our degree will be 2. Next we have negative 4 cubed xy squared. There's only one term here. So that means it's going to be a monomial. Next, we need to find the degree. So because there's only one term, that one term is going to be our leading term. And then for our degree, remember our degree is the sum of the exponents of the variables. So I don't even care about this cube because this cube's going to go with the 4. So I'm just worried about my exponents on my variables. So I have 1x and 2y. So 1 plus 2 will give us a degree of 3. Lastly, example 3, x squared y minus 8xy squared plus 5x plus y to the 6th. So here we have 1, 2, 3, 4 terms. So we're going to say it's none of these. We could just call it in general a polynomial. So finding our degree, our leading term will be this positive y to the 6th. That's our largest exponent, which will make our degree 6. So defining polynomials as functions, next page. So if we have if px equals x squared plus x plus 1, it asks us to find p of 6. So instead of x, they wrote 6. So we're going to do the same thing on the other side of our equation. So instead of x, we're going to write 6. So 6 squared plus 6 plus 1. We're going to plug this into our calculator exactly like we see it. So in parentheses, 6 squared. You can either do the caret button, or right here next to the 7, we have a squared. So 6 squared plus 6 plus 1, which will give us 43. So that answer will be 43. Next, we're going to simplify by combining like terms. We have negative 2x squared plus 4xy minus 2y squared plus 3x squared minus xy plus 3y squared. So combining together our x squareds, we have negative 2x squared plus 3x squared. Negative 2 things plus 3 things will give us positive 1 thing, so positive 1x squared. Next, combining together our xy's, so we have 4xy minus 1xy, so 4 minus 1 will give us plus 3xy. Lastly, our y squared, so negative 2y squared plus 3y squared will give us positive 1y squared. So our final answer is x squared plus 3xy plus y squared. Next example, adding 7y squared plus y minus 3 plus 7y squared minus y minus 7. So because there's parentheses there, we need to get rid of the parentheses. Outside of this first set of parentheses, there's nothing, or it's a positive 1. If we were to distribute a positive 1, we'd be left with 7y squared plus y minus 3, so it's going to stay the same. Outside of the second set of parentheses is still a positive 1. Just for consistency's sake, I'm going to draw some arrows to show that we're distributing that positive 1. So positive 1 times 7y squared will give us plus 7y squared. Positive 1 times negative y is negative y. Positive 1 times negative 7 is negative 7. So we're left with 7y squared plus y minus 3 plus 7y squared minus y minus 7. Combining like terms like the previous problem. 7y squared plus 7y squared will give us 14y squared. Next we have 1y minus 1y, which goes to 0, so they cancel each other out. And then last but not least, negative 3 minus 7, which will give us negative 10. So our final answer is 4y squared minus 10. Last example for this notes section, we're subtracting negative x cubed plus x squared plus 9x plus 12 minus 3x cubed minus 12x squared plus 3x minus 7. Again, outside of this first set of parentheses, there's nothing, or it's a positive 1. So it's going to stay the same, so it's going to stay negative x cubed plus x squared plus 9x plus 12. Outside the second set of parentheses is that negative, so we have to distribute that negative 1 to everything inside the parentheses. So negative 1 times 3x cubed will give us negative 3x cubed. Negative 1 times negative 12x squared will give us positive 12x squared. Negative 1 times positive 3x will give us negative 3x. Negative 1 times negative 7 will give us positive 7. So we're left with negative x cubed plus x squared plus 9x plus 12 minus 3x cubed plus 12x squared minus 3x plus 7. Combining like terms like we did earlier. We have negative x cubed minus 3x cubed. So negative 1 minus 3 will give us negative 4x cubed. We have 1x squared plus 12x squared. 1 plus 12 will give us plus 13x squared. We next have 9x minus 3x, which will give us plus 6x. And last but not least, we have 12 plus 7, which will give us plus 19. So that'll leave us with our final answer of negative 4x cubed plus 13x squared plus 6x plus 19. Now this is Module 2, Homework 6 notes.